In this video, we'll see how to create a function in Oracle that will return a set of records that can be queried just like it's a regular table. The neat thing about this is that the table doesn't ever exist. It's not like we're creating a function that inserts records into a table. It creates the table dynamically in memory and then can use it just as any other table. The context for this example is going to be our small family consulting practice that needs to record counseling sessions for clients and counselors in particular rooms. So let's go ahead and just take a look at what our data looks like. So we're going to select everything from the appointment table for a particular day, and this is what we have. So we have appointments made for counselors and clients in a particular room starting at a particular time and going for a duration. So our hope by the end of this example will be able to have a function that will look through our appointment data and be able to report not what the appointments are, but what the gaps between the appointments are, what the counselor availability is. So to start that, we're going to be building a function that can return a table. So let's take a look at step one for that. First step here is to create a user-defined type that will allow us to express each row in that table. So we'll start with create or replace type. We'll give it a name. I'm going to call this type T underscore for type, counselor available row, and then we say as object. And then it's just like defining a table. We put a set of columns with column names and data types, and just the same way that we would do if we're building a table. So in this case, we're going to go ahead and have three. One for the counselor name, one for the time at which the break starts, and then one for the number of minutes, the duration of that break. We'll go ahead and close off that create type statement, and we'll execute it. So we now have a user-defined type called tCounselorAvailableRow, and it's going to have these three variables as a part of that structure. And so step two for us here is to now create another user-defined type that will be the table that's made up of that row. And so starts off the same way, create or replace type. We give it a name. This time I'm going to call it a counselor available table. But now we say, instead of as object, we say as table. And then we say of some kind of user-defined type. And so in this case, it'll be a table of our user-defined type that we just created. So we're now making a table of that particular kind of row. So now we should be able to close off this statement, and we've now created that type. So we have two types. One is represents for the, or one is for the rows, and then one is a table of those rows. Now we're ready to create a function. So we're going to create this function three different times, kind of increasing in complexity. So our first time, we're just going to create this as a hard-coded table that will return exactly the same table every time. It won't be very useful, but we'll be able to get the feeling for how the syntax works. So we'll start off with create or replace function. We'll give it a name. I'm going to call it counselor availability. And then we're going to establish the return type. Now it's going to return the table, and so our return type is going to be our table type that we have defined here. So this last type that we created, that is going to be the type that we're returning. And so we're now ready to establish how this function goes. So it'll be as, we'll begin the work of the function, and now we're going to establish what this function is going to return. So it's going to return a tCounselor available table type, and now we'll specify what's going to be in that. So it's going to have a row, and the row is going to be a tCounselor available row. We'll then put the values right here as we're defining an instance of this row object. So this first one's going to be for Leslie Wright. It's going to start at a particular time, and it's going to have a particular duration. So we now have one row established for the table, and let's go ahead and bring a couple more in. These next two will be for Quinn Fowler. Again, different start times and different durations. We'll now close off the table. We now have a full return statement, returning a table with those three rows. We'll close off the function, and we'll execute the function. So now this is just a simple function created to be able to return that data. It's not very useful because, of course, the data is static. but we should be able to now query that as if it's a regular table. So we'll say select star from, and then it's tempting here to put just the name of the function, to select star from counselor availability. But if we execute that, we'll say, hey, you're just not allowed to drop a function in here. And the reason is that it's got to be a table, and by default Oracle doesn't recognize that function as a table, even though it's going to return a table. And so we'll try that again. We'll say select star from, but we're going to cast that function as a table, and so we'll say table open parentheses, and then we'll put the name of the function. And now we're ready to execute that query. And so here we have the results coming back from that function. The table that we defined up here is the source for the records that are coming from this query. And it's not just printing this out to the screen, it really is returning those as a table. For example, we can run that query again, but this time put a where clause on it, restrict it just to the counselor Quinn Fowler, and we should be able to see that we can restrict that set in the same way that we would restrict any table. And so this is our first approach, just to return a static table. Let's take the next step towards making this a really useful solution. Okay, so this time we're going to make a version of the function that's a dynamic table, but the values will still be hard-coded. So this is the next step towards getting this to be quite useful. So again, we're going to create or replace function. We're going to give it a name. We'll establish the return type of that same user-defined type that we created. And now, we're going to create a variable. This is going to be a variable to hold the table that we're going to return. So our variable VRET is going to be just a variable that we're using to build the return value. It's of type tCounselorAvailableTable. That's the type that we're returning. And so we're going to be building a variable of this type, and then when we're done building it, we'll just return our VRET variable. So now we're ready to begin the work of the function. So the first thing we're going to do here is we're going to assign that variable to be a table. So we're making a table. Now, unlike when we created that table before, in our last example, we created that table and then we immediately filled the records into it. In this case, we're creating the table, but it has nothing in it. So it's a completely empty table. It doesn't even have an empty row. It is a table with no records. And so we need to now add a record to it. And the way we do that is with the extend method. And so because our VRET is a table type, it has this method extend. So that now gives us a place to put our first record into it. And so we just need to refer to that first element inside this table and plug a record into it. The way we're going to do this is by saying VRET, and then we're going to supply a subscript of the count property of that same object. So this is, since we've just added one record, now there's only one record in it, this VRET count will return 1, and it will refer to the record that was most recently added. Now we're ready to give that a value, and that's going to be a new row. So we're going to use our row type here, and again we'll plug in the information for Leslie Wright. We'll say this is going to be a break that starts at a particular time and has a particular duration. And so this approach here, where we're saying extend and then put a record into the newly created slot of that table, we're just going to duplicate that a couple of times. And so we'll extend and plug in another row, this one for Quinn. We'll extend again and plug in another row, this one also for Quinn, for a different time and duration. Now we're going to go ahead and finish off this. So we're done creating this table. We're ready to now establish the return on this function. So we will just return our variable. So we've created the table and bound it to the variable that we're working with. Using that variable, we've put some records into it. Now we're ready to return that variable. That's what this function is going to return. We are now ready to end the function, and we're ready to run that statement. So now the function's created. We should be able to do something very similar. So select star from. Again, we have to cast it as a table, then the name of our function, and we're ready to execute that query. Again, we get the same results. It's just a different path to get to the same thing. So now we can see we're on the way to be able to have this be a little more dynamic, but still we've hard-coded the values. And of course we can restrict this in the same way that we restricted it before. All right, so now let's take a look at the real work here. And so this is going to be creating a function that will dynamically look at the appointment table and figure out which breaks there are because it's the time that's not scheduled. Now, because we've built this same example, or a very similar example, using a stored procedure in prior videos, I'm not going to go into the details about how we do this, but we'll hit the highlights about how we'll have to change that prior code to be able to make it work as a standalone function that returns a table, rather than inserting records into a fixed table. So, create a replace function. We're going to give it the same name, counselor availability. This time, though, we're going to give it a couple of parameters. So the first one we'll say is, listen, you're going to give us the time of day that the workday starts. So we'll call that parameter P day starts at. The idea here is that if our first appointment starts at 10 o'clock, we need to know that there's a break that goes from the point that the day starts up until that 10 o'clock time period. And so we'll go ahead and default this. We'll supply a default value of this as 9. So if the user doesn't supply a value for this parameter, we're just going to assume the day starts at 9. We'll do a similar day ends at variable. It'll also be numeric, and we'll have this as 17, which is analogous to 5 o'clock. So those are the two parameters that we'll expect to be passed in, but again, if they're not passed in, they'll default to the values 9 and 17. All right. We're now ready to close off the parameter block, establish the return value of the function. It's going to return that same user-defined type that we created for the table. And now we're ready to start the work of the function. Here then are the same variables that we've used in prior examples. We're going to slide in here, again, our return variable, the variable that we're going to use to build the table to return, and it will be of this type that we created, the table type that we created. And now we're ready to go ahead and establish the cursors that we're going to use. Again, this is using 3 cursors, two are nested cursors, one to look across all of the set of dates that we have scheduled, then within those dates to look for each counselor, and then to look at the appointments for that counselor in that date. And again, I'm not really trying to explain this part here because we've covered it pretty well in a prior video. So we're ready to begin. We've defined the variables here. We're ready to begin the work. So again, we're going to establish the initial value for our return variable, and it's just going to be equal to a blank table. So we now know we're going to be returning a T-counselor available table, but there are no records in it yet. And let's go ahead and bring in the statements that we need to be able to get going with our loops. So by this time, we're down into the third cursor, looping through the third cursor, and we've established what the break duration is. At this point, we just want to say, hey, if this break duration is more than 10 minutes, then that's a break that we really care about. If it's less than 10 minutes, we don't even want to see it in the schedule. So if that variable, vBreak duration, is greater than 10, now we're going to go ahead and extend our table that we're returning. So we define that here, that's vret. We're going to extend that, put a slot to be able to hold a record. And now we're going to drop a record into that particular blank row. So our vret variable at the location that we just created, we're now ready to plug in that same counselor available row. So again, we're going to put here now, instead of having it hard-coded, we're going to be putting the variable where we've already defined who the counselor is. So if we look up here, we'll be able to see that we're establishing a particular counselor. So vCounselor is picked up here from one of the cursors. Same thing is going to be true for our date. We're going to pick up the date of this, or when this break starts, again, off of one of these variables that we've defined. And so we'll also do the same thing for the duration. So now we've established variables for the name of the counselor, when the break starts, and the duration. And we're using those values to plug now dynamic values into the newly created row of this table that we're preparing to return. And so that's going to be the end of our insert into this dynamic table. So we're only going to do that if the break's longer than 10 minutes. All right, same thing. Let's go ahead and continue this work that we have at the end. Oh, here we're establishing the new break start time just to get ready for the next iteration on that cursor. And then again, that's now the end of that inner loop. We have to do something very similar at the end of this loop to be able to pick up the break time that goes for the end of the day. So we're looking at the start of the day that the appointment is on, plus the parameter that we've passed in for the ending time. And we're using that to establish the final break duration. And then again, if that break duration is greater than 10, we'll do the same thing. We'll extend and then create the record for that. We're now ready to close off the two loops. Return the table. Now that we're completely done, that those three loops now are all closed, we'll return the table and we're done with the statement that's creating this function. So let's go ahead and execute it. So now that creates that function, and we should be now able to select the records from that table. But this time, the data is being read dynamically from our appointment table. So we'll do select star from cursor availability. And since we've got quite a few appointments in there, let's limit it down to a particular day. So just where the start time of the appointments is the 5th of June, 2018. And so now we can see that we've got that one day of now not appointments, but breaks between the appointments. And we can see it's pretty common for these to start at 9 a.m. because that's when the day starts. All right, so let's restrict this down just a little bit further. Same query, but let's add on a restriction to a particular counselor. And that gets us down to just looking at the set of breaks for James Sawyer. Well, let's look at the analogous query from the appointment table. So now if we look at these together, we should be able to see that at 9 o'clock, he's got a break that goes for 60 minutes. And then his first appointment starts at, would be good if we had sorted this. Let's go ahead and sort that. Okay, so now we can compare his first break starts at 9, goes for 60 minutes, and then he's got an appointment that starts at 10, goes for 55 minutes. He's got another appointment then that starts right at 11, goes for 55 minutes, so that should take him up to noon. And sure enough, just before noon, we see that he's got a break that starts at 11:55 and goes for 125 minutes. That's going to bring him up to 2 o'clock. We see that appointment here. That appointment goes for 55 minutes. That takes us up to the next break that starts at 2:55 and goes for 35 minutes. He then has a final appointment that starts here at 3:30, goes for just shy of an hour, and then the last break of the day starts at 4:25 and goes for 35 minutes. So we can see now that we've been able to split out that data in such a way that we can look either at the breaks between the appointments or we can look at the appointments themselves. And so the next thing I'd like to do is just a little more complex query, and without talking through it too much, we're just going to select everything from a subquery here where we've unioned together the appointments and the counselor availability. Now, to make these union compatible, because they don't have the same number of columns, we'll have to insert some nulls in here where we're selecting from our counselor availability table. But now that should give us the ability to interleave the information for that day. So now we can see the break starts, and then we have an appointment. And then we have another appointment, a break, an appointment, another break, an appointment, and a break. And so this now becomes quite useful. We can either join together the full schedule for the day, including appointments and as well as breaks, or we could query just information about the breaks or information just about the appointments. And so that's what it takes to be able to create a function that returns a set of records that can be used in a query, just like a regular table.